Currently an exploration science and research support scientist at ESTEC, but originally she's from Hungary. She did a Bachelor in Earth Sciences in Budapest and afterwards went on to pursue her Master's and Ph.D. at the Freie Universität Berlin, again in Planetary and Geological Sciences. Then she came to ESA ESTEC, first as a research fellow on planetary surface exploration missions to the Moon and Mars, and then as her current role. So please give it up for Csilla.
Thank you so much, and good evening for everyone. Thank you for joining us today. So I have a very long title, and actually I extended it. So I'm going to talk about human and robotic exploration missions, and the destination is the South Polar region of the Moon. Okay, so the lower. Yes, thank you. So so over 50 years ago, we had the dawn of space exploration. And the Moon has been targeted by two of the nations, the US and the Soviet Union. And here in this image, you see the landing sites of those missions. So the first one was in 1966, the first soft landing by the Soviet Union, and then followed by the US Surveyor lander. And also only the Americans who actually made it not only with robotic missions, but also with human missions. And it has been over 50 years ago, and ever since, the first robotic mission in the new space exploration era was done by the Chinese. The Chang'e 3 landing rover and lander in 2013. And also China was the first nation who actually landed on the far side of the Moon. The previous missions only targeted the near side of the Moon. And also India joined to that club last year to land close to the South Polar area, and also Japan. And here you can also see a view from the Apollo 16 landing module and the Chang'e 4 panoramic image from the far side of the Moon. Oh, yes. So in the new space exploration era, so there are many nations targeting the Moon, and including also again US. So they have a program which is called the Commercial Lunar Payload Services, and NASA is paying money to industry to bring science payloads, science instruments to the lunar surface. And here on this picture you see that there are several missions which are in preparation, and they are targeting different parts of the Moon, but there are several missions also targeting the South Polar region of the Moon by robotic missions, and also with the new human exploration program, Artemis. Okay, so, but an exciting event is that the Chinese will launch their new robotic spacecraft to the Moon on 3rd of May, just a few days from now. And they are going to target the far side again, and will be bringing back the samples for the very first time from the far side of the Moon. And they are targeting this area, the Apollo basin. Most importantly, this rectangle is the landing area. And here on this picture, what you can see is a topographic map of the far side of the Moon, with the yellow areas show highly elevated areas, and the blue shows low elevated areas. All these circles are craters, impact craters. And this large black dashed line shows the largest visible and oldest impact crater on the Moon, which is you can see also on this image mosaic here. This crater is 2,500 kilometer diameter, and it is 13 kilometer deep. So it's a giant impact basin, and this is the target for different nations in the future to go to this location. But not only that, we focus on the south polar area. So you see the South Pole is located over here. South Pole, Aitken Basin, the Aitken crater is here, so that's why it's called South Pole Aitken Basin. So anyways, the South Pole is the target for future exploration. On the left-hand side, you see an image mosaic made by the Lunar Reconnaissance Orbiter camera. And you see lots of dark areas in this area as well. And I will explain them why in the coming slides. And on the right-hand side, you see again a topographic map. The brownish, yellowish areas show you highly elevated areas. This is like a plateau. And the pinkish show you the lowest elevated areas on the map. And the elevation difference is between 7,000 meters and minus 7,000 meters. So it's a huge elevation difference in here. And just to orient you a little bit, because I will mention a couple of locations in this area. So the South Pole is actually in the middle. So that's the South Pole of the Moon. And Shackleton crater, this has been discussed by NASA several times because they are targeting this area. And there are other large craters, Havor, Shoemaker, Faustini, and Cabeus crater. They had an impact in Cabeus before and detected water ice coming out from the plume of this impact event, targeted impact event. Okay, so as I mentioned, that's the next step is Artemis program. So this is the new exploration program from NASA. Unfortunately, they are a little bit in delay. So they were targeting 2023 for the first humans back again to the lunar surface, but then they delayed it to 2026. So hopefully we will see the next humans on the lunar surface by then. So what are the candidate areas where they want to go? This is again the Shackleton crater, South Pole area, and these blue rectangles are showing the candidate landing regions. These are like 25 by 25 kilometer large areas, and they are investigating each of these areas for future missions, not only for the Artemis 3, because Artemis 3 will be the first human mission, but then for the upcoming landing missions as well. But just to give some feeling about how big Shackleton is, this crater I showed you here, this is, so this is the Shackleton crater compared with the Grand Canyon. So the Grand Canyon has a 1.3 kilometer deep, and this crater itself is 4.2 kilometer deep, and it has like 21 kilometer diameter. That's a large crater. The astronauts are not going down there, but they probably walk around it if they really go to Shackleton area, because fun fact is this area has also lots of sunlit hours, and I will talk about that, why this is important on the moon and this particular area. And also, why do we target the South Pole? So the South Pole and also the North Pole, the polar regions in general on the moon, they might have subsurface water ice on the surface and also subsurface and also very close to the surface, so like within the first 1 meter. And this has been proposed already in the 60s, and there have been many missions with using different instruments, scientific instruments, to see whether there is ice or not on the surface and also in the subsurface. So there are permanently shaded areas which are due to the fact that the moon has very low obliquity. Like Earth has 23.5 degrees, but then the moon has 1.5. It's very, very, very low. And then also the topography is very rough, as I explained to you. The sun is coming in very low angle, and then also casts long shadows. But there are some areas where the sun is not directly illuminating the surface. So they are always in permanent shade, and that is very cold. And it means that it's so cold that water ice could remain stable in those locations. So, and some people calculated how many areas in these permanent shades. So in the North Pole, that area is less than the area size of Montenegro, just to get a feeling. And in the South Polar area, it's a bit more. It's like all together, it's like in Slovenia, so the size of Slovenia, the country. Yes, and this picture actually, it shows the Shackleton crater here, and also the last three craters, Hubbard, Faustini, and Shoemaker. But the point here is that these locations with the blue could harbor potentially water ice on the subsurface or on the surface or on the subsurface, and not only the permanently shaded areas can have water ice, but also areas which are also time to time intermittently illuminated by the sunshine, by the sun. And also in this area, just one more thought about it. So when you stand on the lunar surface, so one point can have sunshine for 6 hours or 10 days, but some other you go 1 kilometer away, and then this area has a different amount of hours of sunshine. So when you are targeting your mission, you have to know when do you want to go, because this is a key for your operation time. You want to maximize the operation time, so you want to know which areas are illuminated the longest. Okay, so I'm going into a little bit of details. I'm sorry about that slide, I have no nice picture for it. But then typically landing site assessment, when it comes to that, there are two major factors. Engineering constraints and also the science potential of the landing site. So we want to land safe, so the slopes, so the angle of slopes have to be very, very gentle, so the area has to be smooth. And also we need to know how precisely we can land. Can we land with 100-meter precision, so almost pinpoint landing, or we can do only by few kilometers or tens of kilometers. That is a big factor, because if we are targeting areas which could have this water ice in the subsurface, we need to precisely land on those areas in order to find them. And also the operation constraints. So we want to maximize the time we can be constantly illuminated on the lunar surface. So then the solar panels can get energy for the operations, and also the astronauts can see on the surface, because the South Pole has these long casted shadows, and the sun is always above the horizon when you are at the sunlit area. So it makes it very difficult to work there. So the astronauts, when they go there, they do experiments, they will have equipment, they will collect rock samples, so they need some visibility to do that thing. And okay, so these are the major points. Terrain properties, landing precision, operation constraints, and the science potential. So they want to find water ice. Water ice is interesting from scientific point of view, how this water ice got there, if it's there, what's the distribution, and what is its origin. And then also we want to have water ice if we want to have a future exploration and want to have a permanent base on the moon. We need to have resources like water ice is a good one. But of course we can also go to an unexplored geologic area which hasn't been done before by the other landing missions. So this South Pole Aitken Basin is one of it. So the oldest visible impact basin on the moon. So that hasn't been sampled by astronauts before, but maybe Chang'e 6 will do that not this week, but will be launched this week and do it in May. And other resources could be a factor like metals. We want to find metals, different metals on the surface, and so on. So we combine all the constraints we have for a specific mission. We combine all that. Like the slopes I mentioned, these are 3 maps. The map on the left, it shows like slopes. The blue areas are good, like very low, gentle slopes. The green areas are less good. On the map in the middle, you see Earth's visibility. So if you want to directly communicate with Earth from the South Pole, you need to have a visibility to the Earth. So this map shows you the blue areas. From the blue areas, you don't see Earth. The green areas are good. So from those points, you see the Earth most of the times. And then the solar illumination. So this is an average map. So blue areas show you where there is limited or no illumination, and the green areas show where there is illumination in a certain amount of for a certain amount of time. And then 2 pinkish maps. These maps, both of them show water ice stability. So conditions in which the water ice could be stable on the surface or the subsurface, like 1 meter depth. And if we combine all these maps together, then we get this. So we can have a map which shows us, based on our constraints we give, then it shows the accessible areas. So accessible areas where we can potentially find water ice or other things. But this map specifically shows areas which could be safely targeted by using the constraints we have given. These blue spots. And then the question you might have is, what is the European Space Agency doing in this question? So the European Space Agency has the Human and Robotic Exploration Directorate, and this directorate has 3 destinations: the low Earth orbit, the International Space Station, you see here, the Moon, and also Mars. And we are also helping and supporting the NASA's Artemis program. We are providing, yes, this is a good one. So we are providing the European service module for the Orion spacecraft. And also we are building 2 modules. It's called Esprit and IHAB. We are providing that for the Gateway. The Gateway is the new lunar space station. This will be a new space station around the Moon. There were no space stations before around the Moon, just around Earth. And our goal is to have a European astronaut working on the Gateway at the end of this decade, and also with that, that we will have a first European astronaut on the lunar surface by the end of the 2030s or early 2030s. And an additional element is that we are building a lander which will be capable to bring down 1.5 tons of cargo, and this is supporting also the Artemis mission, and it's called Argonaut. So the new name is Argonaut. It's a very tall lander. You see there's an astronaut here on the surface, right standing next to it. Yes, and that would be giving us the access for sustainable exploration of the lunar surface, and also will grow science and technology in Europe. And just don't read, please, these slides. I want to say that we have instruments on missions of opportunity, so on missions which we are not leading, but there are other nations bringing our instrument to the Moon. And mentioning Niels, it will be on Chang'e 6, so will be launched this week to the far side of the Moon. And also Prospect, which is looking for water ice in the South Polar area. And this instrument and its landing site characterization will be discussed by Sarah just right now. Thank you so much for your attention.
Thank you very much, Csilla. Does anybody have any questions?
Yeah, I have a question. What is, I heard you telling about the importance of water for drinking water for future astronauts, but what is the real importance of finding water? Because I don't suppose you think about life on the moon or something else.
So we are not primarily thinking about life on the moon in these ices, but it's more like the ice could be used for resources, for maybe for drinking, maybe for propellant, so fuel for rockets. So that could also secure our permanent position on the moon, like humanity's permanent position.
Hi, thank you for your talk. You mentioned Earth visibility. Why
Yes.
is that important for communications, I guess?
So most likely, yes, it's for communication. So if we want to talk to Earth directly, then you have to see the planet. But probably when we will be there with a permanent base or with for in the future missions, there will be communication satellites, there will be the gateway there. So this won't be a big factor. But for now, we cannot talk to the far side without having another orbiter relaying the data to Earth. So from the far side, you will be never be able to do that, but yeah, so you have to have a direct visibility or a satellite. Yeah.
So this is also how the Chinese far side of the moon explorer is going to do it within the
They have to have a satellite to communicate with, yes.
Thank you for the talk. You were talking about that the surfaces to be eliminated as much as possible for the astronauts, but what about the radiation, the harmful radiation for the astronauts? Would that be a problem?
In long term, radiation might be a problem, yes. The astronaut, the spacesuit, is not shielding the astronauts from radiation. And the Apollo astronauts were really lucky. They also didn't spend much time on the surface, so like maximum 3 days. So, and they were really lucky because there were no big solar events. So we don't know what would happen if there's a big solar event and astronauts are on the surface. But the solar events can also be predicted, as far as I know, at least for a few hours ahead. And then they could maybe go to a shelter.
But will they also be close enough to the shady spots to go into the shady spots?
So these permanently shaded regions are very cold. So at the moment, it's not discussed that astronauts will enter these locations, but more like robots will go there. They don't know how safe these places are. Yeah.
So there is a lot of interest in the moon with all these missions. So what would you consider the biggest scientific outstanding question regarding the moon?
Oh, so my PhD project was about the early bombardment history of the solar system. So after the solar system has formed, there was like a 700 million years time period when there were lots of impactors impacting the lunar surface, but also Earth. But on Earth we have less craters. On the moon we have lots of craters, and the moon has basically almost a complete impact record. That's the best what we can have. So if we would collect samples, rock samples from different parts of the moon, and using that we could reconstruct this impact history, I think this is something that could be considered great achievement. And then using this information we could extrapolate to other planets as well.
Thank you.
Final question?
Yes. Sorry.
Go ahead.
No, sorry. I know in the 60s the Leiden University was involved in finding a landing space on the moon for the Apollo missions, and one of the what they wanted to find out if the surface was not too much, how do you say it?
Too rough or too high and too
No,
low.
no.
You seek it dust.
Yeah, the dust, the
Dust.
palpable dust. So they were not sure that the Apollo mission would could dive into the dust. And is that no problem anymore? Because I didn't see it in your constraints on finding a good landing place.
I don't think that it's a constraint anymore. So we know that the surface is compacted enough. We don't know how these maybe icy surfaces are, but probably not much different from that. Yes, but the dust in general is a big problem for the electronics. Later on, as the astronauts are on the surface deploying electronics, and then the dust will settle or go there as they walk around on the surface, and they just, yeah.
Okay, thank you very much. Let's
Thank you.
you again. And then we'll now have a short break, so if you want to get another beer, go ahead. So we'll be back in 10 to 15.
Okay.